Okay, for problem like number one, my recommendation again is like always, try to visualize what you're looking at here. So let me draw a picture. All right, so I'm going to put a Cartesian plane down. X and Y axis. I'm going to graph out. Well, you know what? Before I do that, I want to find a point of intersection. So I'm going to set them equal to one another. There's 3x minus 10, 6 minus x. I'm going to add 10 to both sides, and I'm going to add x to both sides. So I got the point of intersection occurring when x is equal to 4. Let me put the point down for you. The point would be 4. This is preliminary work, by the way. And 6 minus 4 is 2. If you put in the other equation, you get 12 minus 10, which is also 2. So 4, 2. All right, let me put that down for you. 1, 2, 3, 4, and then up 2. All right? And then I got, two lines, and one is, 6 minus x. That means it's going to go up 6. Let me see. 1, that's 2. Let's see, 3, 4. I'm counting, right? It's 1, 2, 3, 4. Yeah, about 6 up there. So I'm going to say it looks sort of like this over here. I want to write this down for you. This is y equals 6 minus x. The other one is going to be, let's see, I got to go 10 down. I got to kind of ballpark it and say this is 10 down over here, then something like this over here. Again, it doesn't be that accurate, and I want to put the points down for you. This point over here, let's see, 4, 2. This point over is going to be 0 minus 10. This point over here is, let's see, that's going to be 0, 6. All right? So I think I'm okay. And I certainly know what those lines are. I got to keep reading. It says use the shell method to create the volume obtained by rotating the region enclosed by the graphs as indicated. Oh, about x equals 0. I want to put an x equals 0 is just a line of rotation over here. So it's being rotated like this over here. So the first thing I want to do is I want to visualize a rectangular region. All right? And the thing is that they're asking me to use a shell. So I'm going to say this region over here, this rectangular region over here, is going to create a shell for me. And I want to kind of draw a picture of sort of what that shell would look like to me. It would look like this over here. Again, I'm trying to do the best job I possibly can. And then what I'm going to do, I'm going to cut the shell. Boom, 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 like this. And then I'm going to fold it flat. And you're going to get a region that looks like this. This is the side of the shell. And then you get a thickness to that shell. All right? So looking at it, first thing I'll do is just discuss, my picture and how it relates to that cylindrical shell there. So I'm going to say the top curve is y equals 6 minus x. The lower curve is just simply y equals 3x minus 10. And what I want to do is I want to get the height of this thing. That's going to be upper minus lower. So the upper minus lower, this is the height of this can over here, is going to be 6 minus x minus 3x minus 10. I want to kind of simplify that. It would give me, looking at it, 6 minus a minus 10 is 16. Let me see if I did that right. Yes, 16. Whoops. I'm sorry about that. I just had 6 minus 10 is 16. Let me see what else I got over there. I got, minus x minus 3x. That's minus 4x. All right, so I'm looking at this thing, and I got to do something else. I got to do this over here. I need this length over here. And I want to point out, that's just the circumference. And what's it going to be? It's going to be 2 pi r. So the r is actually what the x value is. So write that down. 2 pi r is just simply 2 pi x. And what's the thickness of this can? dx. All right? So I think I'm ready to write down an integral. I'll put this over here. I'm starting at 0. And I'm going to move up to that value in x, which is 4. Let me take a look at it. I'm going to say 2 pi x times, well, here goes the tough part. I got to do that, that 16 minus 4x now. That's dx. I'm looking at that. I'm going to try to maybe factor it a little bit because I'm thinking the numbers might get a little outrageously large on me. So I'm going to say 0 to 4. I'm certainly going to fill out a 2 pi, but I notice the 16 minus 4x is a 4 I could pull out. So I'm actually going to pull out 8 pi. Be careful about this. That's going to be x. I factored a 4 out, so that's going to be 4 minus x now. dx. I want to keep doing the evaluations down. Let me just make sure you don't do it over here. Put it over here now. It's 8 pi and 0 to 4. And that's going to be 4x minus x squared dx. Going to keep moving forward. 8 pi. I can put the antiderivative down, so it's going to be 4x squared over 2, which would be 2x squared. All right, let me go to the next thing now. What do you get next? Let's see, minus x cubed over 3, right? Let's put the limits of integration down. It goes from 0 to 4. All right, I'm going to start doing the arithmetic here. What do you get? 8 pi. If I put a 4 down, what do you get? You get 2 times 16, which is 32. And then you're going to get minus 64 thirds. Now, if I do the lower limit, I notice if I plug in 0, I would just get 0. I've got some work to do here. I'll write this down for you. It's 8 pi. Common denominator would be 3. And what do you get there? 3 times 32 is 96 minus 64. Got to keep doing it. 8 pi. We'll look at the key later, by the way. That's 3. And 96 minus 64 is going to be 32. Okay, 8 times 32. That's 240. And 16, 256. I'm done. All right, probably the worst thing about that problem was doing the arithmetic. So what I want to do is go back to the key. And we're over here, problem number 1. You know, it certainly did a lot of, scratchy work over here, but we eventually get to it. And I want to just simply check, if I'm getting this over here. I will look at the other part of the key, by the way, and I'm seeing this over here. Now, the question is, did we set the integral up correctly? We did. We said, 0 to 4, 2 pi x. I see that. This over here is, if you look at it, I did the arithmetic, it's going to be 16 minus 4x dx. I did that, okay. This is good. Over here, I factored out 8 pi. Again, I see that too, and I see the limit 0 to 4. It's 4x minus x squared. I definitely got that. Was I able to get the antiderivative correct? I think so. It's right over here. Was that going to be 8 pi? I get the 2x squared, minus x cubed, and 0 to 4. So we did okay. Again, mistakes happen. You want to look at your key and make sure you can, verify that what you're doing is good. Thank you.